Yeah, so I'm kind of semi-retired here. I've been in the oil and gas business and software business for about 40 years. I spent 40 years really in commercial and industrial construction, working for major construction companies and an oil and gas company here in British Columbia. Last 36 years as a project manager and also a software consultant for oil and gas and other linear asset owners. And then I also have 9 years with a data collection software company that is building software to support damage prevention. I also sit on the CSA S250 committee, which is why I posed the question to Paul, because I know DND was gathering data for BIM, and of course, you need accurate data for that. And I know that they were involved as well in the CSA S250 committee. I was just curious to see whether they're actually referencing the standard or not. And I was glad to hear that they do. So here we are. Today's discussion is around how accurate maps save lives. So we want to make sure that we understand how these maps save not only lives, but cost and time. So it adds a lot of efficiencies to the work if you know you're working safe because you've got all of the information that is available and you can trust the information. So our intent here is to improve the trust level and the accuracy of the data that's being provided to workers out in the field, if you will, or people that are putting themselves at risk by disturbing the ground. So we're going to relate how the SUMDEx initiative is going to improve the safety and help. One of the groups that's out there with that has stated goal is the Common Ground Alliance in the U.S. And they want to achieve their goal of reducing damages by 50% within 5 years. And that's very, very achievable. So SUMDEx, as I mentioned, was started off as a Canadian initiative. And we decided to change the name because it referenced a registry, which everybody thought, well, you're creating a separate database. Well, we're actually not creating a separate database. It's more of a federated solution where we provide a snippet of map data from each of the utility owners to fulfill the requirement of a one-call ticket. So that's why we changed the name to SUMDEx. It's really a data exchange initiative, and it's a two-way exchange. We'll get into that in a bit here. So what's the issue and why are we doing this? Well, there's over 2,000 injuries and 400 fatalities in the US from accidental contact with infrastructure in the last 2 decades. And the drain on the economy is an estimated $91 billion. And that's just the US. In Canada, it's well over $1 billion. That's probably closer to 3 billion. So to put that in perspective, in Japan, they have in 2016, they had 134 impacts on infrastructure for the entire year. We have pretty much one every minute in North America. So it's not 2 per year, it's 1 per minute. It's incredible how often infrastructure is struck. And there's a bunch of reasons for that. But the main reason that they don't have that same incidence, if you will, or same frequency of impacts in Japan is because they map everything. It's part of the permit requirement to deliver an accurate map of where it's going in. They have to do an accurate as-built of its as-installed location and make that available in real time. So when somebody puts in a permit, they can access existing maps and understanding what's there and then react to it as part of their design work to make sure they can avoid clashes, if you will. So the aim of this presentation is to understand how the data exchange system is going to improve existing map records and reduce the number of buried infrastructure damage events. We'll get into that a bit further here in a slide or so. Oh, I see you've got a spelling error here. North American One Call Centers. I'll have to fix that. So the solution that we're proposing, and which is the one that's literally being built out and tested currently by Minnesota One Call and the folks there, is the One Call Center. So it's a communication conduit between excavators and utility owners to support utility damage prevention. And they've been around for close to 50 years. In fact, some have just recently had their 50th anniversary. So every state, every province has One Call system in place. And that's where you call before you dig, or click before you dig now. So the process is the excavator contacts the one call. The one call looks at the dig area that's been identified by the excavator. They look at their maps and figure out who actually has installed utilities there. They contact those utility companies. The utility companies review the location of the work and the location of their assets and decide whether they can give a clearance because the work is far enough away from their assets. Or if they're not comfortable with giving a clear, they would send out a locate service technician. So the locator will go out and mark the infrastructure locations on the ground with paint or flags or stakes. And then it's up to the excavator to ensure that they understand exactly where everything is and not damage it during their work. So some of the challenges with that, accurate dig site depiction. Of course, if somebody's just calling it in, they're describing where their work is, and hopefully they get it right so the agent understands exactly where the work is. And quite often they put big buffer zones around it to make sure that they don't get it wrong, if you will, that they more than adequately covered the dig site area. And they may then over notify the owners, and the owners will have to send somebody out because they don't really have an accurate understanding of where the work actually is in relation to their physical assets in the field. And at times it overwhelms the system. So there's a challenge is trying to respond on a timely basis. Usually it's within a couple of days, 2 to 3 days. But when there's a huge backlog, it could go further longer than that, in which case there's delays and that sort of thing. So contractors are held up waiting a clearance or waiting for utility locates. Quite often when they get behind, utility locators are pushed to get as much done as quickly as they can, which may or may not result in an accurate locate. And a lot of that could be helped if they had accurate utility location records already to start with to understand what's supposed to be there and where is it supposed to be. So they've got then a sort of a jump on an understanding what should be there when they go to do that locate. They can then confirm they've located everything, do a sweep to make sure there's no unknown facilities in the site, and then inform the one call to give what they call a positive response so the contractor can go to work. So as I mentioned, the current process, there's issues with it, and statistically, 1,400 line strikes every day in North America. And there's, like I say, one every second day in Japan. And Japan's got 1/3 of the population, by the way, of the US. So quite a striking difference in terms of capabilities in terms of preventing damage. The human cost, of course, there's significant injuries, fatalities. There's direct and what they call direct and indirect costs or societal impacts. So that's the direct damage costs, work delays, loss of services, traffic disruptions, business disruptions. CGA in 2020 had identified in their DIR report what that was. We can get into that in another slide or two as well. And the Contractors Association also identified costs associated with lack of trustworthy and actionable information. And they put that impact at $61 billion a year just in the US alone. Just because they don't, sometimes they have difficulty understanding the information made available to them, or there's delays, and they have to second guess everything or double check everything. So we need to work on that. So that's where accurate mapping comes in. So accurate maps are critical for reducing damage by providing situational awareness to workers, engineers, and contractors in the field. Right? So the recommendation that came out of the CGA's next practices pathway report in 2021 identified the need for accurate, accessible maps, which is exactly what we're up to here. We're trying to improve the existing map records by leveraging the work that's being done in the field. And again, we'll get into that in a second or two here. And in terms of mapping standards, I mentioned CSA S250, there's ASCE 38, ASCE 75, PAS 128 in the UK, and there's an Australian standard. So pretty much every country now in the world every developed country has developed mapping standards to improve the data collection accuracy out in the field. So this is a picture. This is a piece of data collection software is used to gather as-built in the field. This is subsequent to the SU work. This is a resultant map from the SU work in the field. And most of this depiction here is decimeter accurate. Some of it is even millimeter accurate when they've got it opened up and it's visible. So it's collected to AS 83822. This is on the C70 project in Denver. I also mentioned the requirements here. So there's a bunch of requirements around exchanging the data, which is what we're all about. We're gathering data in the field, comparing it to information we got from utility owners, and then reconciling the two. And what, in fact, the owners will reconcile it. We'll just send them back the file that was collected in the field. They can compare it to their existing records and then investigate any discrepancies or certify their existing records if they happen to be coincident. So the requirement is to provide a secure bidirectional data exchange between utility owners, designers, damage prevention stakeholders, and emergency responders. In terms of the format, the data exchange will use common geospatial file formats to reduce the need to transform them. And somebody mentioned FME earlier. That's what they do. They transform or exchange, allow the exchange of different file formats without reducing or without impacting the data quality, if you will. And the other thing that we need here is accuracy, and that's where these standards come in. So for the most part, when you're doing locates, you're accurate to, let's say, a decimeter or two at best with the locate tools that are out there. And it depends on the depth and the type of tool being used. But then it also depends, if you're talking about geospatial accuracy, it depends what type of satellite receiver you're using too, if you are indeed using a satellite receiver. All right, so here's the standards that we refer to here. And there's the covers of the various standards. There's two here in the US and Canadian standard. And the US standard is also used in certain places here in Canada as well. So they can use either CSA AS250 or the ASE 38 and 75 standards. So what's the point of doing all this? Well, here's a good example. And this was kind of the genesis for my getting interested in establishing this initiative. And it was this Colorado DOT project. And what they did, Colorado DOT was doing a massive highway widening project. So the highway ended up being much, much wider than it was originally. And they actually went down and lowered it down as well. So there's a lot of existing infrastructure in place, a lot of issues with impacts on a previous project they had, the I-225 project, which was about 10 miles long. They had quite a large number of line strikes on it. It's the same density of utilities on this project. So they were quite concerned about project delays and costs due to line strikes. So what they did, they reached out to the utility owners through the one call centers, and they got the utility owners to submit map files to them. So they got the centerline information from each of the utility owners, and they manually conflated all of those files into a common format onto a common base map, and then gave that to their designers. So that's where they started. So it was with the design work. Then once they got the design done, they engaged, or a good part of the design done, they engaged the SU company to go out and confirm the precise location of all of those features that were out there. And then they went back to the designers and said, okay, here's the what's actually out there. They did their clash detection and adjusted their design before they went to bid. Now, when they went to their bidders, because they had all of this accurate information that was signed off, if you will, by the SU company, so the bidders knew that it was good data, trustworthy data, if you will, the bid prices were quite a bit lower. So the results, there was less redesign because there weren't any surprises when they actually went to do the construction. Bid prices were lower. And from the previous project, they had reduced their damage incidents by over 90%. So they went from about 330 damages on the other project to less than 30 on this project. They shaved months of schedule off because they had built in some of the schedule had an allowance for delays for line strikes. And they did have some line strikes, as it turns out, but the majority of the line strikes were unreported fiber lines that weren't even reported to the one call. So nobody knew the fiber was there. And the fiber companies didn't want their competitors to know where they had fiber in the ground. So they were delaying notifying the one call center as to where their fiber was. So that was one of the issues that they came across in this project. It was just most of the strikes were fiber. So the initiative, so when I kicked this off, one of the first phone calls I made was to Jeff Zeiss, and Jeff put me on to the folks at Minnesota. And so we elected to work together. So the intent of Minnesota 811 and our intent as well was to provide a free application, and they're calling it Fusion Views, developed by Gopher State One Call and their geomatics firm that they've engaged in Minnesota to support the exchange of buried infrastructure in North America. In fact, in the world, they're making it available for free to everyone that is in the damage prevention business, if you will. So every one call, any government or state agency that wants to host it, I guess, could host it. Here in British Columbia, we have maps. Instead of doing locates like most places in North America, they issue you a map. So this is a perfect process, if you will, for British Columbia, where they're already sharing a map. And what we're doing now is we're going to collect the data in the field and provide that feedback to the map owners, if you will, the utility owner, to update and confirm the accuracy of their records. So the basic process is that Fusion View just uses the one call ticket as a vehicle to request data from the utility owner. It'll pull it into the Fusion View portal or the SUMDEx portal, and it will then publish that in the portal. Once the excavator gets the positive response back from the one call center, then they know they can proceed with the work. And they've got literally one map to look at, and they can switch layers on and off and understand exactly how these how the infrastructure, this existing infrastructure, relates to each other, and also how this might be how it might impact the work that they're planning to do, so they can make sure they avoid the infrastructure. So again, the one call ticket is just a vehicle to exchange map data between stakeholders. So what that means is the current one call process does not change. You still go out, you still mark the ground, you stake it, flag it, tape, whatever it is, paint, or if it's SU work, then you're just out there with an understanding of what's supposed to be there, confirming what it is, and getting all that valuable data back to each utility owner. So the benefits, of course, it's going to advance project safety, reduce cost, improve schedule performance, and we're also going to pass, if you will, we're going to take that legacy infrastructure location records from the owners and provide the field location, field verified location data back to each utility owner to improve the records. So in sum, accurate maps and data exchanges will enhance damage prevention capabilities. In this picture we're seeing on the right-hand side here, it looks like a wet street. That's oil. And that was the line strike that was in Burnaby here in British Columbia in 2007. And there was a major oil spill. This was happened within a quarter mile of the ocean. And the oil ran down into the sewer system, which had outfall into the ocean, of course, so there was oil slick in the ocean. The oil also got sprayed up in the air. It was a windy day, and the wind carried the oil. It sprayed about 40 feet into the air, carried it for about 1/8 of a mile, covered a bunch of houses in oil. We're talking over a dozen houses, and these are multi-million-dollar homes on the waterfront. So there's a huge cleanup cost as well. So this was, of course, one of the reasons why there was a call to action to get something done here. So the whole thing about the data exchange is going to improve the safety, improve timelines, reduce costs, better project performance, and also provide 3D data to support BIM initiatives. That's one of the things that does not happen today. There's a lot of work that's being done out in the field, subsurface utility engineering work, so pre-site and construction, pre-construction site investigations. That work's being done, but the data doesn't go anywhere except to the client that requested the information. It doesn't, that information is collected in the field on the accurate location of those assets, does not currently, for the most part, go back to inform the utility owners whether their records are good or they need to be adjusted. And that's a travesty, if you will. So the intent here is to add value to all the work that's being done in the field and make that anything that can add value to utility owners, we're going to make it available to them. Right, so the call to action here is to invest in an accurate mapping and data exchange system to protect underground infrastructure. The other thing that we mentioned was, again, FME. One of the, in fact, it was the city of Burnaby here that you're seeing this, where this accident happened. The city of Burnaby automated the notification response for one-call tickets. So when they get a one-call ticket from BC One Call, what used to take them a couple of days to put together for a design ticket request, let's say, would take them 2 days. They've automated the system, and now it happens within 3 or 4 minutes. So those maps are literally, the ticket will go and be applied to their database as a spatial filter. They pull the information out of their GIS system, or their CAD system, and they make that available in about 4 or 5 different formats. So there's CAD, there's GML, sorry, not GML, KML, KMZ, shapefile, GDB, and even, I think, even a CSV file. And then they send that off to the ticket requester, and then the ticket requester can consume that in whatever file format they want. And they save well over $120,000 a year just by automating that process, and it runs 24/7. So there's a huge cost savings to the city of Burnaby by automating that process. So this will enable that for everybody. So once the information is available electronically, the data sharing can be almost real time. So it can be secured, encrypted, it can be sent through email, it could be sent through an endpoint. All kinds of things can happen here depending on what your needs are. And with that, I guess I can close it. So I've got some contact information here. So there's myself. There's our SUMDEx website. I invite you to visit that. Gover State One Call, as I mentioned, was the initiator of the software side of it. And also like I said, it was a parallel solution that was being done at the same time, which is why we're working together. And there's Barb's contact information there. And Barb is the CEO, actually, well, not COO of Gover State. And then Steve Swayze, who's the Minnesota Geospatial Advisory Council. And he's also the president of Shared Geo. And Shared Geo are actually building out the software. And they've got their website there as well, fusionview.org. Right? So the floor is open for audience questions. John, over to you, sir.
Hey, Steve, thanks so much for that update. That was great. Yeah, everybody, if you've got questions, please put them in the Q&A. I'm going to start us off asking a pretty big question. So it looks like there's traction. I'm seeing a lot more discussion about underground infrastructure mapping and trying to get us all on the same page. Why do you think now is so much different than, let's say, 20 years ago? Why does it seem to have finally, because it's not like damage wasn't happening or these problems didn't exist and we suddenly realized that we could fix them. Is it because of, this is a bit leading, but is it because we didn't have anything like a muddy model?
Well, that's part of it. So there's a bunch of things came into play here. So one of the big ones was the development of certain technologies. So locate tools and ground penetrating radar, for example, are much more effective than they used to be. I mean, 20 years ago, if you looked at a locate tool, you look at it today and it would be laughable, but it's, you know, it's what they had in the day. It wasn't very accurate, but it worked. You know,
How bad were they?
Some people use dowsing rods, right? I mean, you know, whatever works. So that, I mean, that's pretty old technology right there. So anyway, so there's been major improvements in the locate tool technology. There's been major advancements in GPS. As we all know, now your cell phone can get sub-meter accurate if you've got the right type of cell phone. Got some Qualcomm chips now that are sub-meter. There's tablets and computer technologies really help. So Bluetooth, for example, where I can currently Bluetooth a locate tool to my tablet and collect data and have it populate a point in my tablet. And I can also tie that into a GPS and not only plot the point, but plot it accurately within millimeters if I've got an RTK solution and using a range pole, for example. What else we got going here? Like you say, the standards, the mapping standards, the muddy standards, everybody's starting to understand that just like self-driving cars, if we didn't have accurate maps and technology, those cars cannot drive themselves, right? And even your navigation. Back 20 years ago and look at you know, your navigation tool in your car, it would leave in the middle of nowhere sometimes, right? But it would get you there, but it would get you to nowhere. So now we have very accurate maps to navigate with and using our automobiles. We want to do the same thing with subsurface maps, subsurface utilities. Understand where it is, how far we are away from it. So again, it gives us that context, if you will, that situational awareness, which is all important about creating a safe environment.
Very true. We have a question from the audience. I'm going to read it from Dwayne. Agreed, collaboration is key for improvements to data and mapping. Do you hear the comment that it is cost prohibitive from many buried facility operators?
Well, I guess here's the question. Here's the one thing that I brought up that I always think about. It's not your homeowners that are causing the damages that are out there. I'm not digging in my yard and hitting any infrastructure except what's on my property. And unless somebody has a right of way, I'm not damaging their, you know, their major infrastructure. I'm hitting a small service line, and it's pretty much my fault. There's no question, right? But if I'm a utility company installing some new infrastructure, I'm actually putting other infrastructure, pre-existing infrastructure, at risk. So whether I'm working on a highway widening project and I'm putting in storm drains, or I'm putting in street lighting, or whatever it is, it's usually another utility company that damages the utilities, which means that the cost of that damage, right, gets borne by the utility company customers. So if it's, you know, let's say it's the city, like that happened in Burnaby, for example, here. The city of Burnaby was doing a sewer widening project. And it was a contractor working on behalf of the city to hit the infrastructure. So the city had a small fine. The contractor had a small fine, relatively small, and the utility owner had a small fine as well. But the cost of that was in the billions. So people don't realize the end cost of that particular line strike is much, much more than the 15 or 20 or $40 million it costs to pay reparations to the homeowners and clean up the mess. It had much more far-reaching and long-lasting impacts. All of the protesters came out of the woodwork here in British Columbia. They protested every project for a decade, more than a decade. In fact, they're still protesting lines today. And this is it's almost 20 years later. So there's a huge cost to that. So and this is all being paid for by the consumers, the taxpayers. So somebody has to pay for it, and it's not going to be necessarily the utility companies, it'd be their customers, or it'd be the taxpayers or consumers. So yeah, we're talking $91 billion worth of impact in the US alone every year.
Yeah, it's a huge number.
It's a huge prize.
Mind-boggling.
So if we could reduce that by 50% within 5 years, which is what the CGA goal is, we're talking $45 billion a year in cost savings.
Yeah,
Somebody has to pay for those damages and the impact. So that's why this is such a great initiative, and everybody benefits. So in terms of cost of projects, just think about it, John, that less risk, less cost. If we can reduce the risk through better information, the costs go down.